Hello and good afternoon to Mr. Jeffrey. I am IKHWAN SYAMIL from School of Engineering, Mechanical Engineering. I would like to present our project for today, which is solving manufacturing line problems. So the objective of our project will be reducing the defect rate of the most consuming part process in coating process for bright coat companies in Berhad. So in order to reduce the defect rate, we need to reduce the waste from color powder from the cyclone, which gather from the cyclone, which is sucked by the cyclone. So we would like to save more profit for the company and increase the revenue for the company itself. So the solution for our project will be separating the two lines of dark color gradient and light color gradient and interchangeable cyclone, which is we need to clean it thoroughly and dissect it and clean it thoroughly. Yes.
As you can see, these are the processes that merchants need to go through the process, and which concern about water using, decreasing, etc. So we have detected that the most defect rate contributed is by the process of coating and spraying.
This is an example for the rejected materials for our project. And next is the cyclone that we are cleaning thoroughly to reduce the defect rate for our project.
We want to do initiating the project itself. We would like to resolve the high cost of high defect rate for the project, for the streamline. So the priorities of our project, for the scope, we would like to reduce the defect rate by cleaning the cyclone. And for schedule, we would like to finish our project by doing coating as engineering finished by the coating saw. And for the budget, we have no budget at all since since the company itself sponsors us to do the experiment in the company. So the proposed idea would be millions of ringgit since the machine is quite expensive. Last but not least is the quality. We need to do a maintenance for the cleaning the cycle.
The risk that we are having in this group is to maximize the business value, to choose the most optimum solution, and to optimize the chances of achieving the objective, which is to reduce the defect rate. As you can see in the work breakdown section, I'm doing the conceptual design and mechanical parts. Meanwhile, Juni is doing the research since it is his own company, Faris is doing the prototype, and Izmira doing the altering design, while Iman, who easy to be moving around, find and gathering of materials. For the planning for our project, it can be seen in the network diagram below. Since week 1 of our project, it took us about 1 week to determine the main problem, 3 weeks to find the solutions for our problems, 1 week to design the solution, and 1 week to design the 3D model before buying the materials, which took about 1 week for us too. And it took us about 2 weeks to create the prototype before finishing the project. The critical path for our project took about 8 weeks in total.
So the time estimation for our project to be finished should be most likely by week 13. And being optimistic, our project will be finished by week 12, and being pessimistic about week 14 by the engineering fair day. And we have calculated the mean, which is 13 weeks, and the standard deviation will be 0.60 weeks. So for the cost for our project, we have divided into 3 parts, which is managing cost, the prototype cost, and the appraisal cost. So managing cost will be our cost for drive to the factory itself, since it's not nearby to our place. The second one is prototype, since we are building prototype. Since the actual machine costs about thousands and millions of ringgits, we need to build a prototype. And last but not least is the appraisal part, appraisal cost, which is the evaluating the experiment and observing the results of the experiment itself cost.
This is the result for before and after cleaning the cyclone, which is 10% before cleaning and 90% of defect rate before after cleaning the cyclone thoroughly by dissecting it. To execute this project, we need to visit the factory and brainstorm ideas for the solution for our problems. We also do the prototyping and create tool for the section of the cyclones. The opportunities and threat that we are having while delivering this project is the no cost for implementation, and the factory is already built with the machine in it. Meanwhile, the threat is high evaluating and quality costs, and it is hard to be done. For controlling and monitoring, did we follow the plan? For schedule, we late at designing, and we got a delay of 2 weeks. over budget, there are extra costs for prototyping, and for communication, some ideas are not implemented because of some misunderstanding between the group mates. This is the graph of our project. The estimated cost would be 0 ringgit since the company said they would sponsor us to execute our experiment. But adding the total cost of our transportation and the total cost of our prototype, it leads to about 100 ringgit in total.
As you can see, this is the achievement for our group. We managed to clean the cyclone, dissect the cyclone, and interchange the hose connecting the cyclone and the booth from 90 minutes of downtime to 30 minutes. There is about 200% of downtime reduced. So the contribution of myself to the team would be the conceptual design. I designed the wheels on the cyclone itself and the booth hose, and also the clip or the bolt, detachable bolt for the cyclone, so it's easily to be detached and dissect, so we can clean thoroughly and reduce defect rate, and also the mechanical parts, which is the bolt side. The overall performance for our team, everyone able to do and did their designated work and area of job accordingly and effectively. There are some issues regarding delay and lag about the paperwork and also the design, and also the cost of due, but at the end of the day, we managed to do the project successfully, and it's now 80% done by the time the video is made.
Bang bang, bang bang bang.